sklearn Gaussian process kernel's hyperparameter. Description explain in detail. Inputs. A set of training data points. Represented as an array of shape n samples. N features. Where n samples is the number of samples and n features is the number of features. The corresponding target values for each training data point. Represented as an array of shape n samples. A trained Gaussian process model that can be used to predict the target values for new data points. The predicted target values for new data points. Steps. The Gaussian process model is trained using the training data and target values. This involves estimating the hyperparameters of the kernel function. The trained model is then used to predict the target values for new data points. This involves computing the covariance between the new data points and the training data points, and then using this covariance to make predictions. Metrics. Mean squared error MSE measures the average squared difference between the predicted and actual target values. Root mean squared error RMSE the square root of the MSE. R squared R measures the proportion of the variance in the target values that is explained by the model. Visualization plots. Scatter plot of the predicted target values versus the actual target values. Plot of the predicted target values with confidence intervals. The length scale parameter controls the smoothness of the kernel function. A smaller length scale results in a more wiggly function, while a larger length scale results in a smoother function. The signal variance parameter controls the amplitude of the kernel function. A larger signal variance results in a larger amplitude, while a smaller signal variance results in a smaller amplitude. Confidence intervals. These intervals provide a measure of the uncertainty in the predictions made by the model. Predictive distributions. These distributions provide a more complete picture of the uncertainty in the predictions, as they include information about the shape of the distribution as well as the confidence intervals. Challenge 1. Overfitting. The model may overfit to the training data, resulting in poor performance on unseen data. Sample use case that resulted in Challenge 1: training a Gaussian process model with a very small length scale on a dataset with a lot of noise. Fixes to Challenge 1: use cross-validation to evaluate the performance of the model on unseen data. Regularize the model by adding a small amount of noise to the diagonal of the covariance matrix. Use a different kernel function, such as the RBF kernel, which is less prone to overfitting. Challenge 2: computational complexity. The computational complexity of Gaussian process models can be high, especially for large datasets. Sample use case that resulted in Challenge 2: training a Gaussian process model on a dataset with millions of samples. Fixes to Challenge 2: use a sparse Gaussian process model, which only considers a subset of the training data points. Use approximate inference techniques, such as variational inference or expectation propagation.